All right, so here is our Quiz 8 review, looking at trigonometry and a little intro to probability. All right, so first up, if you're given a trig ratio, can you find a new one? So first up, if theta, if the reference angle is in quadrant 2 and cotangent has a ratio of -0.9 as a fraction, that'd be -9/10, which is the adjacent to opposite. Can you find secant? So secant would be hypotenuse to adjacent. Okay, so second quadrant puts us over here. So I'm going to connect back to the origin and then back to the x-axis. Label my reference angle right there. Okay, so from here, the adjacent side must be the -9. Opposite would be 10. Right, that makes sense because left would be negative, up would be positive. All right, so now Pythagorean theorem to find the hypotenuse. A² plus B² equals C², or use the shortcut because we're trying to get the hypotenuse. So square root 10² plus 9². So 100 plus 81. So square root 181 doesn't simplify. So here is the opposite, adjacent, hypotenuse. And we want secant. So we're looking at square root 181 over adjacent -9. So where you put the negative doesn't really matter. It could be closer to the top or the bottom or the fraction bar. Still reads negative. All right, next up. Okay, this point lies on the terminal side of theta. Find cosecant. We want the cosecant ratio. So cosecant would be the hypotenuse over the opposite. All right, so 6 -3 puts me right about there. Connect to the origin, back to the x-axis, make the right triangle. Here's theta, that's my reference angle. So write 6, down 3. Find the missing hypotenuse. So square root 6² plus 3². 36 plus 9 is 45. Okay, 45. Well, that's 9 times 5. So 3√5. Okay, so now cosecant, that ratio, we just label here. We need the hypotenuse in the opposite side. This is the adjacent side. Okay, so I need 3√5 to -3. Those 3's cancel, 1 to 1. So cosecant theta produces -√5 once we're fully simplified. All right, next up to the unit circle. All right, so we want to evaluate each trig function. We want to make it exact, simplified. So we should see roots when it's appropriate. All right, so secant 240. So secant is the reciprocal of cosine. So flip x. All right, so 240 right here. Here's the x. We flip it. So 2 over -1, -2. All right, tangent. So y over x, -270. I could also add 360. Find a coterminal angle of 90. Either way, right? Both of those options work. So if I'm reading it negative, right, I'm going in this direction, 90, 180, 270. And if I'm reading it positive, positive 90. So here I want y over x. So 1 over 0. Can't have 0 on the bottom. Undefined. All right, next up, sine. So sine, we're looking at the y, and we want 870. So here, if I want a coterminal angle, I could subtract 360. Maybe I do it twice. So really, I'm subtracting 720 to get in range of my unit circle. So sine 150. So right here, looking at the y, 1/2. All right, next up, cotangent. So cotangent, x over y. We want 5 pi over 3. So I'm looking right here, cotangent, x divided by y. So I have 1/2 divided by -√3 over 2. So 1/2 times 2 over -√3. Those 2's cancel. 1 to 1. So I have 1 over -√3. And then we rationalize. So I multiply by √3 over √3. And I get -√3 over 3. All right, cosecant. So cosecant is the reciprocal of sine. So here, I'm just going to say flip y. Okay, and if you want it to be positive, add 2 pi. So in this case, if I kept a common denominator, that would be 12 pi over 6. So a coterminal angle would be cosecant pi over 6. Okay, pi over 6. Here we go, right here. And I'm looking at the y, and I want to flip it. So 2 over 1 gives me 2. All right, cosecant, not cosecant, cosine, right? Cosecant, now cosine. So cosine, we're just looking at x, and I'm out of range. So remember here, I can try to find a coterminal angle. So maybe I subtract 6 pi over 3, right? That would just be 2 pi. But I still have 11 pi over 3, still not in range. So maybe I subtract again. So really it's like taking away 12 pi over 3. So coterminal for cosine would be 5 pi over 3. All right, so then looking at x, 1/2. All right, next up, we're graphing, but we're not telling you how to label your grid. So we have to identify all of those variables. So first find A, find the amplitude. So here I don't have anything out in front. So 1. Okay, B. Okay, so my B value right here is 2. Means I have a horizontal shrink by 1/2. So here, if I look at my period, which for my parent is 2 pi, if I divide out that B, it confirms that my period is now half of what it was originally, so just pi. And then we see a shift right, so 3 pi over 2 to the right, right? That's the C value, tells me left, right. And then the D value right here tells me 1 up. Okay, so that tells me where my midline is going to be. Okay, so when I make my scale, I want 2 cycles. I want 2 periods. So I'm going to start by maybe counting, let's see, maybe 1, 2, 3 notches to here. That should be plenty. Okay, and since it's only going to go up 1, I can kind of keep this centered to here and adjust if needed. Okay, and I'll scale the y-axis where this is 1, this is 2, -1, -2. Okay, and then my y-axis, if 1 period is pi, I need that to be right about here, and this to be 2 pi over here. So let me look at my notches and figure out how to make that work. I think that looks good. So I'm going to go 8 over. So 1, 2, 3, 4, 5, 6, 7, 8, right there. I'm going to mark that as pi. That's going to be 1 period. Go another 8. Here will be 2 pi. That will be 2 periods. Okay, now break this into quarters. So take half of where pi is. Here, right, that would be pi over 2. Okay, and then in half again, here, here. So these are really quarters of pi. So pi over 4, this would be 2/4, which is a half. This would be 3/4, right? This is 4/4, so just 1 pi. We do the same thing over here. So from pi to 2 pi, mark the notch that cuts it in half, and then half again to make quarters. So if that's 4/4, this would be 5/4 of pi. 6/4 would be 3 pi over 2, and then 7/4. Okay, now think about what your parent looks like for cosine. Okay, so here for my parent, right, I would start here. I do this in pencil. Okay, starts at 0, 1. Here, 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 and here. So that's just 1 cycle. That's 1 period of my parent. But I want to move it up 1 unit and write 3 pi over 2. Okay, so my midline should be here at 1. Okay, so the point here should be down here. Okay, but I need to move it right 3 pi over 2. So the point that's right here would now be right here as my starting point, right there. So then I'm going to go to the midline, below it, like that, and then I'm just going to complete the pattern in the opposite direction. Okay, and then I'm going to make my beautiful wave. All right, there's my cosine graph with all of those transformations. All right, next up, can we write the function? Sine or cosine? Answers can vary. Always, always find your midline first. So if this is my max and this is my min, so 4 up, 2 down, if I average those, so 4 plus -2 divided by 2, 2 over 2 is 1. So there's my midline. So min was -2. Max was 4. Midline, right, we averaged them. And 2 over 2 got us 1. Okay, looks good. So A, distance from midline to a max or to a min is 3. That's my amplitude. Okay, my period. So 1 full cycle of it. So if I go from here, this max, to this max, that's 1 period. And that's from here to here. So my period spans 2 pi. Okay, so then if I want B, okay, my period is 2 pi, or my B value is 2 pi, my parent period, divided by the period I see in the graph, which is also 2 pi. So the B is just 1. Okay, C, well, if I think of this as cosine, because cosine usually starts, like if this is my midline, cosine starts on the y-axis. So if I think of cosine being right here, I can see that there must be a shift off of that y-axis that is 1/4 pi to the right, because if this is 1/2, this is 1/4 of pi. So here we would say pi over 4, 1/4 of pi to the right. And D, my midline is up 1. All right, so I would write this equation as cosine. So y equals 3 times cosine, parentheses. Okay, the B is 1, so I don't need to write that. It's implied. And then x minus pi over 4. That's my shift to the right. And then 1 unit up. Okay, now an application problem. Okay, we love a good Ferris wheel problem. So here we go. Let me make a little model. So a little circle for the Ferris wheel. A little stand right here. Okay, so it's 120 feet in diameter. So that means that my radius would be 60, and 60 to make that 120. And it completes 2 revolutions every 5 minutes. Let me highlight that. Okay, the lowest point is 10 feet above the ground. So here is 10. So I can see that right here would be 10 feet. And then this, when I add the 10 in those 60s, would be 130. So I know that my min is going to be 10. My max will be 130. And my midline, the average of those two. So add them, divide by 2, so 70. Okay, so then also I have to unpack, what is 1 period? Why am I told 2 revolutions for every 5 minutes? So 2 revolutions equals 5 minutes. So then 1 revolution would be 2.5 minutes. Okay, so now let me just read more. At time 0, the rider's the 10 feet above ground. So right there, graph and write a model for the height in feet of the chair as a function of time in seconds. Okay, so I want this in seconds. So let me multiply this by 60. Okay, and that would tell me that 1 revolution in seconds is 150 seconds. So keep in mind that that is 1 period. 1 revolution, 1 period, 150 seconds. All right, so then we make our picture. Do a little sketch of it. Okay, min 10, max 130, midline 70. Okay, here is time in seconds, and then height as a function of time, and those units are feet. Okay, we are starting at time 0, 1 period here, 150 seconds. So split that in half, and then half here and here. We've broken it into quarters. So half of 150 is 75. Half of 75, 37.5. Okay, so if I'm going up in increments of 37.5, here is 112.5. So again, this is 1 period. Okay, so we start at a minimum right here at 10 feet. Okay, and then we gradually get higher until we hit that maximum height, come back down, and then that cycle continues. So if I draw in my graph, it looks like this. Okay, and the fact that I don't start on the midline tells me it's going to be cosine. So cosine usually starts here, right? We're 0, 1, but here we see that there's a vertical stretch. There must be a flip then also. So my A, right, I can see that I am 60 units away, max to midline, or min to midline. So A is 60. But since there's a vertical flip, we'll say negative. Again, that's because of the vertical flip. Okay, B, 2 pi divided by the period. 1 period is 150, right? That's seconds. So pi over 75. Okay, C, there's no horizontal shift. 0. D, the midline is up 70. All right, so I would write this as height as a function of time equals negative 60, cosine, parentheses, pi over 75, t plus 70. All right, flip it to the back. Let's do one more. Okay, so here researchers find a creature from an alien planet. Its body temperature, B, varies sinusoidally with time, T, 35 minutes after they start timing. It reaches a high of 120 degrees Fahrenheit. 20 minutes after that, it reaches its next low, 104. Okay, so let's unpack the details. We're told that the min temperature is 104, right, degrees Fahrenheit. Max is 120. So our midline, we average them. So add them, divide by 2. So 224 divided by 2, 1/12. All right, let's make a picture. Okay, here's our min, max, okay, midline, okay, and we have time, x-axis, and then we have body temperature as a function of time, okay, y-axis. All right, so we're told, let's see how to do the x-axis. So here we're told that body temperature, we're given 35 minutes after they start timing, it reaches a high of 120. Okay, so here's time 0. Here would be that 35, right? That's the first data point we have. And then 20 minutes after that, it reaches its next low. So 20 minutes after that, we'd say 55. So it'll start high, get low, but we're going to need it to get high again for one period. So if I do another 20 minutes, this would be 75. Okay, picture little notches in between, like that, which would be at 45 and then 65. Okay, so then, again, 35 minutes after they start timing, we're at a high of 120. Right, the low is at 104, and that's 20 minutes after. That's right here. So here is the in-between, and then it comes back up like that. That's one period. That's one cycle, and it's going to keep, again, repeating, repeating, repeating. Okay, looks like that. All right, so again, this is a period, and that span is 40 minutes. Okay, so this looks like cosine again, but no flip, no vertical flip. We do see, though, a shift, right? This is not right on that y-axis where it's body temperature, right? It's over here, 35 units. So there's really a horizontal shift, 35 to the right. So let's list out the variables. So the amplitude, so that span is 8 units. KB, 2 pi divided by the period of 40 gets me pi over 20. C is the shift. And again, that point right there, right, should be here. So we're 35 to the right. C is 35. And the midline is up 112. Okay, so when I write it out, body temperature as a function of time equals 8 times cosine pi over 20, right? That's my B, tells me any stretch or shrink horizontally, parentheses, T minus 35, right? Because that's time, closing both sets, and then plus 112. All right, there's my equation. All right, next a little bit of probability. So calculate the independent or dependent events. So independent, we're saying that one outcome has no influence on another. And dependent, we're saying one outcome does influence the other. And a good rule of thumb is think about how your numerator is impacted, how your denominator is impacted from stage to stage. All right, so first up we have 12 kids in a club. 7 boys, 5 girls. What's the probability a girl is picked to be president and another girl is picked to be vice president? All right, so first girl picked, we have 5 out of 12 total kids. We want to pick another girl, but now I have one less girl and one less total kid to pick from those kids in the club. So 4/11. Okay, so type in 5/12 times 4/11. There's the decimal. Put it as a simplified fraction. So 5/33. Right, this situation was dependent. Right, that first pick of girl influenced the next pick. All right, multiple choice test. Each question has 4 choices. There are 6 questions. Student guesses. What's the probability that all 6 are correct? Well, that's totally independent. One pick has no influence on any of the others. We want 6 correct picks, and each correct pick has a 1 in 4 chance. So really 1 in 4, we're writing it out 6 times, or saving time by writing 1/4 to the 6th power. So 1/4096. All right. Next up, there's a drawer. We have 14 white socks, 6 black socks, so 20 total. Okay. You randomly choose one sock. Do not replace it. So that tells us right away, dependent. The fact that we're not replacing that second pick is influenced by what happened first. Okay, then you randomly choose another sock. We're looking for the chance that both are black. So first pick is black, 6/20. We don't put it back. We pick another sock, also black. We have one less black sock, one less sock total. So 5/19. Okay, multiply across. Simplify the fraction. We should get 3/38. All right, marbles. A bag has 10 red, 15 blue, 5 yellow marbles. So we have 30 total. You randomly select 3 marbles from the bag with replacement. So that means that we're putting each marble back before we draw again. So that means this is independent. We're looking for the chance we get a yellow marble first, then blue, then red. So yellow, blue, red. All right, first pick is yellow, 5/30. That yellow goes back in the bag. We pick again. We have 15 blue, still out of 30 because that first marble went back in the bag. Okay, we draw one more time, right? The blue goes back in. Red marbles, we have 10 out of 30. Okay, multiply across, reduce your fraction. We get 1/36. Easy peasy. So again, you're just thinking about what is changing from stage to stage. If it's independent, right, that's easy. If it's dependent, how has the top changed? How has the bottom changed based on what happened previously? All right, next up. We have 15 PE teachers, 25 coaches, so 40 total, attending a workshop. We're going to pick 3 of them at random for a special lecture, and we want to find the chance that none are PE teachers. So if none are PE teachers, they must all be coaches. Okay, so that is a dependent situation because we're not picking the same person more than once, right? They have to be different coaches. So first pick is a coach. We have 25 out of 40. Okay, next pick, also a coach. But now I have one less coach and I have one less total participant. Last pick, it's a coach again. One less coach, one less participant. So again, multiply across, simplify the fraction. We get 115 over 494. All right, one more variation. According to the American Academy of Ophthalmology, 18% of the U.S. population has hazel eyes. All right, so our U.S. population is massive. Our U.S. population is about 340 million people, right? We rarely see numbers that big. That is massive. So this creates an independent situation because our sample size is so big. Specifically, it's less than 1% of our population. So what this is saying is, if we pick 3 people at random from this massive population, 3 people is not going to alter this figure of 18%. That's going to stay fixed because we're picking from a pool of people that is in the hundreds of millions. So pulling 3 people out, this figure stays put. So we're saying all of them have hazel eyes. So hazel first would be 0.18. Hazel second, still 0.18. Hazel third, 0.18 again, right? 0.18 to the third. All right, so 0.18 to the third. So we would get about 0.0058 for our probability. Okay, what makes these two different, I like showing you these back to back, is that this one, we're picking from 40 people. Of course we feel a difference from stage to stage when we remove one person from a group of 40, but we're not going to when it's out of 340 million. All right, last question. All right, so a local high school surveys students. They ask about your dominant hand. Are you a lefty? Are you a righty? So we're given results as joint relative frequencies. So we're just seeing it proportionally in our table. Round to 4 spots. So what is the probability that a randomly selected female is a lefty? So this is a conditional probability. Think of the structure, both over the given. So in this case, females and lefties, but we're picking from our pool of females. So females who are left-handed, 0.048 out of the total females, 0.497. No, sorry, 0.498. Well, I read that wrong. That figure, 0.498. All right, we crunch it. Okay, 4 spots. So 0.0964. So our lefties among the females. Okay, how about a right-handed student is male? So again, conditional probability, both over the given. So right-handed and male from among the right-handed students. Okay, so right-handed males, right there, 0.398. From among all of those that are right-handed, so 0.848. Okay. So here we would get 0.4693. All right, last up, determine whether being left-handed and female are independent. Okay, so what that means is if they are truly independent, the proportion of individuals who are lefties should be the same in the entire group as it is among the females. So we need to look at the probability of being left-handed. So right there, 0.152. Okay, and then we're looking at the probability of being left-handed among the females. So left-handed and female among the females. Okay, we did already solve for that. I'm just going to recopy that work. So 0.048 left-handed females among the females. And that gave us 0.0964. So we're seeing that they're not even close. Not close. Which would signal to us then, right, those figures are so different, about 15.2% lefties overall, and only 9.64% among the females. We would say not independent. If they were independent, we would expect to see that it would be within 1/100th or 1%, right? That would be close enough to call something independent. All right, you guys, have a good rest of your day.